Hello students, welcome to KlassPM. We are discussing about NMR spectroscopy. In the previous class we have seen the basic, what is NMR. We have said that nuclear magnetic resonance spectroscopy, and this part of nucleus, the composition of nucleus and everything we have discussed in the last class. Today, and this is also we have discussed the magnetic. What is that magnetic? Magnetic, that every nucleus, while it is spinning, nucleus is having positive charge because the proton charge is the charge of nucleus, and it is rotating. Every charged particle, if it is moving, it produces a magnetic force, so it acts like a tiny magnet. Since it is acting like a tiny magnet, by using right hand thumb we can decide which is the north direction, which is the south direction. Since it is rotating in this direction, and this is the north and this is the south. See here this is there, so this is north and this is south, and this is north and this is south, and this is north, this is south, and this is north and this is south. So nucleus will act like a tiny magnet. So we have discussed about nuclear and magnetic. And what is resonance? That we will study in this topic called the basic principle of NMR spectroscopy. How NMR spectrophotometer works, that we are going to discuss today in this class. See here, in the absence of external magnetic field, the nucleus rotation can be any direction. See, it can be rotate like this, or it can be rotate like this, it can be rotate like this, it can be rotate like this, it may be rotate like this, it may be rotate like this, it may be any direction it may rotate. The orientation can be any way. This is the way we are seeing the different orientations. There are different orientations of the nuclei in the absence of external magnetic field. But if you bring nucleus into the magnetic field, and this here I put my magnetic field, this is north pole and south pole, between them there is a magnetic field. For in this I have brought my nucleus, so that what happens immediately, here we know that, see, if this is a magnet, this is north pole, south pole, the magnetic lines always move from the north direction to south direction, north to south, north to south, always they will move from the north to south. Here the external magnetic field direction is towards this way. This is the direction of electromagnetic field. So whenever you put a nucleus in the external magnetic field, what happened? It aligned itself in the direction of external magnetic field. It aligns itself in the direction of external magnetic field. How it will align? It will align, it north will be close to the, because north is attracted by the south and south is attracted by the north, so that it will align in this way in the direction of external magnetic field. So this is the direction of external, this is the way it will arrange. Now here comes our NMR spectroscopy. Now here I am sending some electromagnetic radiation to this one, which is in the external magnetic field. Since this external magnetic field is having some strength, if I want to flip that, I am sending some energy of electromagnetic in the form of electromagnetic radiation, and this is not absorbing. Here I kept the detector to observe whether absorption is taking place by this nucleus or not. To detect that, I put a detector here. This is a detector. Now at particular frequency of electromagnetic radiation, what happens? It is absorbed, so that immediately it flips, and this side north came and this side south came. This is the way. When the frequency of changing magnetic field in the nucleus matches with the frequency of electromagnetic radiation which we are incidenting on the nucleus, which is in the presence of external magnetic field, then the nucleus will flip, and that it will come north towards north and south towards south by absorbing that electromagnetic radiation. Here comes the topic called resonance. What is the resonance here? Here the frequency of changing magnetic field in the nucleus matches with the frequency of that incidenting electromagnetic radiation, then it absorbs that energy. By taking that energy, it flips, and north will come in the north towards the north of external magnetic field, and south will come in the, this is the basic principle how an electromagnetic radiation. Now here it is having low energy. See, if I say that earlier my nucleus is here, this is along the applied magnetic field here, and it is having the less energy. What happened here? For the nucleus I have given the electromagnetic radiation, and it is absorbed that electromagnetic radiation and it went into which state? Here my free nucleus is there. Okay, when I put it in the external magnetic radiation, what happened? Its energy has been decreased and it is aligned itself along the applied electromagnetic. Its energy got decreased. That's why it is having less energy. But when I give the electromagnetic radiation, the changing magnetic field in the nucleus frequency matches with my incidenting electromagnetic frequency. Then it absorbed that energy and immediately it went to the higher energy state, which is against the applied magnetic field. Then this is having the greater energy. This is the basic principle of NMR spectroscopy. Now here we are. I hope you understood what is the resonance. Resonance means when your electric nucleus, which is in the which is having spin along the applied magnetic field, when it absorbs the energy from the electromagnetic radiation, it changes its orientation against the applied magnetic field. That is called resonance. Both are in same resonance, same frequency. When both frequencies are matches, how detector will show? Because this is the energy curve. See here, detector energy will keep on going. Whenever, see, the energy of electromagnetic radiation is keep on going at particular frequency, that point, what happens? This nucleus absorbs the energy so that the intensity of incidenting electromagnetic radiation decreases. Again after that it's normal. So this amplitude will indicate intensity of absorption, how much energy is absorbed by the nucleus, so that how much energy gained by the nucleus. This is a curve we will see in the detector. I hope you understood what is the basic principle of electromagnetic spectrum, and I hope you understood what is the basic principle of NMR spectroscopy and how a nucleus behaves in the absence of magnetic field, in the presence of magnetic field. And we'll continue our lecture in the next class.